Question 6. A pole BD is attached to point C by 2 wires. As shown, how far is point C from the base of the pole? So how far is that means you're looking for distance DC. Right. Here we can make use of the sine rule, and we're going to use, because we have side B, AB, we need the angle that faces that side, and that we can easily get it by using the properties of a triangle and also angles in a straight line. So this angle should be 180 minus 28 because they are in a straight line. So that is 152 degrees. And because this ABC is a triangle, we are going to add 152 to 16 and to check what angle remains, and you'll get that this angle here is 12 degrees. This is the exact angle that faces side AB. So why are we targeting that? We are targeting that because we need to find side AC. So if we find side AC, we'll be able to use a trigonometric ratio to find DC and use it angle 28 degrees. So you can comfortably say that 16 divided by sine 12 degrees should be equal to side AC divided by sine 16 degrees. So 16 degrees is the angle that faces side AC. So we'll be able to get side AC by multiplying 16 to the other side, I mean sine 16 to this other side. That will be 16 sine 16 divided by sine 12. And we just one more time to confirm. So we'll have 16 divided by sine 12 is equal to AC divided by sine that. All right, so we have AC. So if you have AC, we can comfortably use sine rule and say sine 28 degrees will be equal to opposite, which is side DC, divided by hypotenuse, which is side AC. So if you want to get DC, you should multiply AC times sine 28 degrees. And we know what AC is from up there. So DC or CD will be equal to AC, which is 16 sine 16 divided by sine 12 multiplied by sine 28 degrees. DC or CD is, these are quite different. Let me just say CD because of vector direction. If you understand vectors, either way, the magnitude, we are just looking for the magnitude. We are no longer interested with the direction here. So we use a GDC to do 16 sine 16 divided by sine 12, then multiply by sine 28. We'll be able to get an answer of 9.958 with three significant figures. That should be 9.96. We have units, it's meters. 9.96 meters. So how far is point C from the base of the pole? So point C is 9.96 meters from the base of the pole. Right, question 7. While exploring the Hawa, the Palace of Winds in Jaipur, Thailand, committed an angle of elevation of 15 degrees in this position. From his position on the ground to the top of the tower, Okay, so let's say this is where the eye level is. Let me draw a nice line. So talking about 15 degrees at the angle of elevation. Taylor now estimates moving 10 meters closer. So this guy moved 10 meters closer. Let's say the 10-meter goes here. So 10 meters closer. And now it estimates that it's 18 degrees because you are looking at the same top here. And then we can have some line meeting the ground at 90 degrees. So 18 degrees. How high does Taylor estimate the tower of the Hawa Mahal to be? So we're looking for this height edge. This is some similar questions from what we did in somewhere up here. Yeah, should be this question 3. So it's a similar approach. So we are looking for h. So because this is a straight line, we will we'll find the angle that faces the 10 meters. But we need to find this angle first. So because it's a straight line and angles in a straight line add up to 180, if you subtract 18 from 180, you get that this angle is 162 degrees. And because you already have 15 and you already have 162 degrees, you're going to find the remaining angle up there by subtracting the sum of those two angles from 180. So you subtract that and you'll get this angle is 3 degrees. So we are going to get the hypotenuse of this smaller triangle here so that we can use a sine rule of 18 opposite of hypotenuse to find h. All right, so let's go with that plan. We can use sine rule and say 10 divided by sine 3 is the same as, let's call this hypotenuse capital H, H divided by sine 15 degrees. So 15 is facing my capital H, that's why I'm using that. So capital H will be equal to cross this sign to this side. So we'll have 10 sine 15, and then we still divide by sine 3. I'm not going to write the exact answer for that. I'm going to use it by using the trigonometric ratio of sine. So sine 18 degrees should be equal to opposite h divided by hypotenuse capital H. So for you to get small h, you have to multiply capital H to sine 18 degrees. What will that give us? That will give us h, which is 10 sine 15 degrees divided by sine 3 degrees, then times sine 18 degrees. So use that, use your GDC, and you should be able to get your answer as 15.3 meters. So that is how high the tower is. So find the area of the triangle. So area of the triangle, we know we will need two sides and an angle between them if we are going to use that. But because we don't have an angle, another side here, we can call it side A for us to use these two. We're going to find it using sine rule. And you will see 78 faces that side, but our A faces an angle which is not there. But we can get it from the property that the sum of angles in a triangle add up to 180. And if you subtract that, the sum of these two angles from 180, it will be 180 minus 78 plus 55. Using your GDC, you should be able to get this one as 47 degrees. So we're going to use sine rule, and we'll say A divided by sine 47 degrees is the same as 4 divided by sine 78 degrees. So we'll get our A is 4 sine 47 divided by sine 78. Because of accuracy, I'll use the same value to find the area, which is half AB sine theta, the angle between the two sides. So our A is 4 sine 47 divided by sine 78 times B, which is 4, then times sine 55 degrees, which is the angle between them. If you are GDC, you should be able to get your answers 4.90 squared millimeters. So that is the last part of the previous exercise.